Hey everyone, I'm Jerry, co-founder CEO of LlamaIndex. Yeah, thanks to Arize for hosting me. We've been great partners with Arize for the past 2 years, so really excited to be here and give this talk. And yeah, you guys should all check out, of course, Phoenix. With LlamaIndex, we have really nice integrations. I'll go into that in just a bit. So the topic of this talk is basically on building agents that automate knowledge work. This has been kind of an ongoing theme in some of the conversations in the past few weeks to months. But basically, the idea of this is how do you actually build agentic architectures that lead to knowledge work automation beyond what you can get in a RAG chatbot? RAG chatbots are pretty boring. How can you actually make use of your data in the right way? For us, we're specifically interested in unstructured data. So specifically, if you think about the massive amount of paperwork that exists out there in the enterprise, PDFs, PowerPoints, if you're a consultant, your entire job is to basically just read information and create slide decks, and so for the first time, AI agents can actually do a lot of steps of this process end to end instead of more heuristic techniques, with traditional robotic process automation or computer programs. So really the capabilities of, or the promise of AI is to actually translate a lot of your unstructured context into reasoning and actions to solve certain types of use cases. And we're specifically really excited about the potential of AI agents over unstructured data. So for those of you who aren't as familiar with LlamaIndex, we started off as an open source framework. That's how we got in touch with the Arize folks in the beginning. In the beginning, we were very focused on just building LLM maps of your data and providing the right toolkit to do so. A lot of initial use cases were on RAG chatbots. These days, we have a very comprehensive ecosystem that contains both the AI agent framework that's free and open source. We have these deeply customizable event-driven agent workflows that lets you build multi-agent systems from scratch. And then the second is the document understanding and processing, the ability to actually process and structure massive amounts of unstructured docs so you can provide those as tool interfaces to your agents. Okay. There will be 3 main parts of this talk. One is, to actually build an agent that automates knowledge work, what are the main pieces? I think I mentioned this in the panel this morning, but in the world of MCP, where there's a bunch of agents interacting with the external world, you're either building the agents or you're building the tools. So the first step, especially if you're trying to adopt AI agents in the enterprise and ground it in enterprise context, is to build a nice document toolbox or an MCP server to give it access to all your unstructured data. The second is once you have the set of tools in place, figuring out the right set of orchestration patterns over your agents. And then the third is, we had some fun demos that I'm happy to share and just hopefully walk you through some of the cool stuff that we've built. So the first part is building a document toolbox. We're specifically interested in documents. I'm not saying documents are the only source of enterprise knowledge. Obviously, there's SQL databases, workplace apps, Salesforce, whatever. But this is basically kind of giving you an idea of a generalization of this idea of RAG. Instead of thinking about RAG, we should really just think about how do we provide the right tools to AI agents to access unstructured data. And so let's just say you have a ton of docs in SharePoint. You're like an insurance company. You're processing claims or processing applications. You have a ton of policies, like millions of documents stored in some file store. How do you actually centralize and process and structure that context so your AI agents can even interact with it in the first place? You do need some pre-processing for this to work. I'm sure many of you who have built some RAG pipelines, how many of you have built RAG pipelines? Okay, great. Have probably dealt with some of this, at least in a POC format. One is you need to have some sort of data connectors to your data source, whether it is Microsoft SharePoint or S3 or Google Drive. The second is you need to actually have a layer to do document understanding. So document parsing from your unstructured data, like PDFs and PowerPoints, into a well-represented markdown format. The third, and this is optional, but you could have a layer for extraction too, like a metadata layer that allows you to extract out structured information from your unstructured data and use that as annotations. And then lastly, these are things that you're probably all familiar with, at least in kind of a simple setting. Like, how do you index your data? You chunk them, do some embedding, put them in your favorite vector database, and then retrieve from them. So a lot of these steps sound similar, are basically like what you need to do for RAG anyways, but I'll dive into a little bit of some of these to basically give you a sense of why it's actually important. And the end goal is not necessarily just vector retrieval. It's basically like an entire set of tools for an AI agent to access your data. So vector retrieval is great for semantic search of looking up kind of specific pieces of information. You could also have like a file tool, which allows you to look up the metadata or look up metadata of certain types of files, list like your file directory, get entire contents of a file. How many of you have played around with MCP? Like, okay. How many of you have played around with the file system tool on MCP? Okay, so for those of you who have played around with that, you kind of know what I'm talking about. It's basically like an MCP server that you can plug into Cloud Desktop that allows you to interact and manipulate files on your hard drive. Not really RAG, but an important part of your toolkit to understand your data. And so, this is not a comprehensive list, but this idea that I kind of want to just highlight is this idea of a document MCP server, right? So it's just a set of tools that allows you to access, your unstructured context in some form. And there's benefits to having like a multitude of tools because it allows you some flexibility in how you choose to interact with this data. You probably still need a centralized indexing retrieval layer for fast lookup of context. You probably still need some sort of other operations too to let you actually crawl directories and do deeper actions or searches, as well as like manipulation. And you'll see this with Microsoft Excel. Some file formats are just not amenable to like chunking at all. Instead, you really should just create a set of operations to let the LLM write some code to basically interact with and manipulate the file. A big challenge that we deal with, as you can tell, a lot of the theme of this section is on like the data quality, is on complex docs. So, a lot of docs have a lot of tables, charts, and images. They have like headers and footers. They're multilingual. And, if you use PyPDF or an off-the-shelf parser, a lot of times you render the data in a poor format, and you're just not going to get high data quality, which is going to lead to hallucinations. So one just quick note on this idea of like parsing and extraction. It actually really is one of the core steps towards like, digitalizing paperwork or more generally helping you set up some unstructured context foundation for your agents. There's a lot of OCR solutions out there. Our base open source repo, if you use our framework, integrates with like PyPDF. But these days, a lot of people are interested in adapting Gen AI models to help you do large-scale document understanding. So you combine, VLMs where you screenshot the page and then ask the model to output the text with, just traditional parsing techniques to help minimize hallucinations and give you like good table layouts. And what we did is basically, you combine the capabilities of VLMs and LLMs, combine it with these parsing techniques with agentic parsing, and that's basically how you get really high performance over your data. This is a benchmark. I've shown this a few times, but just to give you a sense, a lot of our capabilities are around like document processing, which is kind of like the first step towards helping you build AI agents over your data. We integrate with like our favorite models, Sonnet 3.5, 4.0, OpenAI, Gemini. We each pay them like a decent amount of money. And then basically it outperforms a lot of the existing stuff out there, both proprietary and open source. Here's some more examples. If you have a table, you probably want to actually do some extraction into like a markdown format, so then you can do some analysis down the road. You probably want some sort of layout detection with confidence scores, just so you can surface that to a human with human in the loop. You also probably want some sort of like structured extraction that allows you to extract out normalized data regardless of the input data type. And then lastly, if you have an entire collection of data, it still helps to have like a centralized indexing retrieval layer. This is one of those things where building a POC for RAG is pretty easy. Building something that's a little bit more production quality is a little bit hard. Or just more generally, building like a centralized index that is actually production quality. If you have a lot of data with multiple data sources are constantly updating, you're going to need some sort of production grade pipelines that can sync data from your data sources into your data sinks, sync permissions, be able to actually handle retrieval at high scale with low latency, and then allow you to actually more dynamically fetch context instead of top K vector search. Great. So that was that part, which is, to actually build some sort of agent that can automate knowledge work, you need the right tools over the data first to actually structure and prepare your context. Now, the second piece is on various types of agentic orchestration patterns that we've seen. And, we're all probably reasonably familiar at this point if you've talked to, or if you saw Joao's talk or saw our panel this morning with all the frameworks, that these types of frameworks are really helping you just build various types of agents with various types of constraints. You can either build something that's super constrained, or you could build something that's a little bit more general. You just give it a system prompt and let it figure it out. For us, we're really excited about just generally understanding the use cases, which kind of informs the overall architecture of these agent reasoning loops. And so there's really two types of UXs that we see pop up for agents. There's one, assistant UXs. So assistant UXs are what we call, or we call them assistant UXs. They basically help surface information to a human faster. So ChatGPT, basically any chat interface, like deep research, things that you look up stuff and you get back content for you to consume, kind of falls within this category. The human is basically interacting with this copilot or assistant with a high degree of human in the loop. It's actually usually a little bit more open-ended. The agent can choose to do, if it's doing deep research, break down your question into a bunch of subtasks, fetch information from a lot of different tools, combine it together, and kind of ask you a question to see if this looks right or not. And then the output is basically some sort of synthesized information, and the idea is that you can then consume that information and use it to make better decisions. If you look at a lot of use cases within the enterprise, whether it's financial due diligence, customer support, enterprise search, a lot of it basically falls within this category. The other piece that we're starting to see a little bit more of are these automation UXs. So automation UXs, in contrast to just giving information to a human, it's more about actually performing end-to-end tasks and making that repeatable. So imagine any kind of repetitive task that you do in a digital manner, whether it's moving stuff from a spreadsheet to another spreadsheet, or reading information from a page and creating a summary out of it with bullet points. These are all things that can generally be repeated across a lot of different types of input data. So the UXs here we see are more around being able to batch process a lot of jobs, reviewing the results with some sort of batch review, human in the loop at the end. And the output or the goal is to actually solve these tasks end to end with some human input, and not necessarily to give the human a lot more information. And so some of this type of more operational work includes stuff like claims processing, invoice reconciliation, normalizing and extracting data from kind of public filings, being able to consolidate balance sheets and more. A lot of it, if you think about a human doing it, is just you clicking your mouse and moving things around. And we basically see agent UXs fall into some of these categories. And that's important because, when we think about the types of agents that automate knowledge work, they're either helping provide the human with more information or helping them, get work done a little bit faster. One general thought, especially with MCP, is that, especially if you think about this idea of automation agents, what is it really doing? Part of what it's doing is basically removing the burden of prompting from the user and just automating something in the background. With these models these days, if you just draw it out to the limit, models are getting infinitely good. The main barrier to actually getting value out of these models is you figuring out how to actually prompt them to basically make sure it gets back the output that you want. And so you being able to design some sort of workflows and capture that and put that into tools is actually pretty powerful, because it means if you then provide this tool as an MCP server and distribute it across all your users, they don't need to reinvent the wheel. They can just call the tool with some input and it'll perform the task end to end. So I think it's actually quite interesting. I think a lot of people are going to be building these sub-agents that can plug into more general agent front ends, and a lot of it's going to start to look like these kind of automations that you build and define. This is just an example of some video that I hacked together by trying out Claude Desktop. But the idea here is, we're very excited about like documents within the space of documents. There's a lot of different types of knowledge work. For instance, doing some sort of extraction from a bunch of like financial statements. Here it's like a single packet of PDF and looking at all the numbers and consolidating them, putting into a pandas data frame. And so, as a user, you don't have to do that anymore. You can just build an agentic workflow that basically does this and then plug it in as a tool and then use your favorite agent front end to basically trigger these types of actions. So in this case, it's Claude Desktop. You can also use, ChatGPT, Copilot, Cursor, or whatever. Obviously, I'm sure many of you are familiar with some of the patterns for agents, but to actually build any of these agents, whether it's more constrained automation-based or assistant-based, generally it helps to have certain things that makes it a little bit nicer from a developer side of things. One, you would ideally like to visualize what's going on under the hood. Two, you want some controllability. So if it's a long-running agent test, you want the ability to step through and actually take a look at every single step of execution. You want the ability to manage your state, like understand kind of the overall context you're managing at any given point, what you're injecting into the context window, and if it fails, being able to checkpoint and rewind. And so, we have a pretty deep integration with Arize. And so if you use our workflows to basically orchestrate any of these different agent patterns, you can basically, with one line of code, toggle the integration, and it'll basically log all the traces into Arize Phoenix. Okay, cool. I have about 3 minutes, so I'm going to run through this really quickly. There are some cool use cases that we help solve. These days, a lot of our stuff is more around kind of unstructured data understanding. So if you have a lot of like agentic workflows that depend very heavily on massive volumes of unstructured data, come talk to me. Here, there's examples in private equity where you're dealing with a lot of data in a data room. This is just like an invoice processing use case from a very large energy company. And then there's also Excel. And I'll show a little bit of this, but Excel is a fun category of use cases to talk about because basically, nothing really works in terms of traditional RAG or text to SQL. And a lot of knowledge work is basically figuring out how you take as input some Excel sheets, build some models, or do transformations on top of it, and then kind of create new types of information that you distribute to other users. So we're working with a few projects here, and we came out with like a public preview of an Excel agent recently. This is actually what I'm going to show in a bit. And so, okay, I guess this is like a straight live demo. But basically, this is kind of an example of a preview wrapper of an app that we built. It's effectively a demo over this Excel data. And we build a semantic map of any input Excel sheet that you feed as input, and then we model it and provide specialized tools for an agent to interact with. So it's much better than your baselines of RAG or text to SQL, and we can basically feed in some input data. Let me just see if it's pulled up here. This is just an example of kind of like an example spreadsheet that you could feasibly use with this agent. It's not quite like a 2D thing. There's gaps in the rows. There's a lot of rows. There's a lot of subsections too. And this kind of goes into the idea that, along the lines of the document toolbox, you can basically feed this data in and then start asking questions over it and then see if you get back the right response. So if I go into Finder, I'm going to go here, upload. And then I'm going to ask, what are the top 3 operating expense categories? Give me 1 sec. Okay, 1. Okay, so what it's actually doing is it builds like a map of all the tools, or of the sheet itself, exposes a set of tools to an AI agent. You can see how it's actually reasoning over it. And then at the end, it's able to give you the final results. I think I'm wrapping up right around now, and once this finishes in 20 seconds, I'll just show the final results. Just to give you a sense, what are the top 3 expense categories here? If I go back into the spreadsheet, it's like the employee costs, right? It's like this section. There's a bunch of categories right here. Consultants, bank merchant charges, occupancy, and more. I'm gonna go back, and then you can see it aggregates all the values. It looks at all the operating expenses, and it aggregates it and gives you back the final answer. So anyways, hope this was interesting. Basically, build the right tools, build the right agent reasoning loops, and that's basically it. Thank you.
Cool, awesome. I think since we're going to break soon, we probably have time for one question from, anyone have any questions? Sure.
For instance, in this example, like Microsoft could certainly implement like an Excel kind of observability system, right, using their partnerships. And also, you could also think, well, maybe data should not be structured in Excel going forward because it's not structured enough, and maybe we can find new ways of getting people who only know Excel today to import their data using like prompts. It's just big picture, using that as kind of a framing. How do you think about going forward in 5 years, 10 years? Like, if that makes sense?
Yeah, for sure. I think basically part of the question is like whether we'll use existing containers of knowledge or kind of invent new ones as the years go on. I think there'll probably be more native formats amenable to kind of both humans and LLMs as more and more agents take over. I do think that some of the power of agents is the ability to integrate with just existing systems too. If you look at all the research work going on with like computer use, it's basically computer use on your own operating system. I'm sure like a few years down the line, someone will create a more native agent OS, but it's just kind of like nice as, I guess, from a development point of view to just like also use your existing stuff. And so I do think our point of view is try to solve the existing stuff first and then just adapt to new data formats as they come up.